Directory clients and servers. Directories are usually accessed using the client-server model of communication. An application that wants to read or write information in a directory does not access the directory directly. Instead, it calls a function or application programming interface (API) that causes a message to be sent to another process. This second process accesses the information in the directory on behalf of the requesting application via TCP/IP. The default TCP/IP port are 636 for secure communication and 389 for unencrypted communication. The results of the read or write action are then returned to the requesting application, as shown in Figure 4-1 on page 84. The request is performed by the directory client, and the process that maintains and looks up information in the directory is called the directory server. In general, servers provide a specific service to clients. Sometimes the server might become the client of other servers in order to gather the information necessary to process a request. The client and server processes may or may not be on the same machine. A server is capable of serving many clients. Some servers can process client requests in parallel. Other servers queue incoming client requests for serial processing if they are currently busy processing another client's request. An API defines the programming interface that a particular program language uses to access a service. The format and contents of the messages exchanged between the client and server must adhere to an agreed upon protocol. LDAP defines the message protocol used by directory clients and directory servers. There are also associated LDAP APIs for C and Java languages, and ways to access the directory from a Java application using Java naming and directory interface, GNDI. The client is not dependent on a particular implementation of the server, and the server can implement the directory however it chooses. 1.1.4 Distributed directories. The terms local, global, centralized, and distributed are often used to describe a directory. These terms mean different things in different contexts. In this section, we explain how these terms apply to directories. In general, local means nearby, and global means that something is spread across the universe of interest. The universe of interest might be a company, a country, or the earth. Local and global are two ends of a continuum. That is, something may be more or less global or local than something else. Centralized means that something is in one place, and distributed means that something is in more than one place. As with local and global, something can be distributed to a greater or lesser extent. The information stored in a directory can be simultaneously local and global in scope. For example, a directory that stores local information might consist of the names, email addresses, and so on, of members of a department of a work group. A directory that stores global information might store information for an entire company. Here, the universe of interest is the company. The client that accesses information in the directory can be local or remote. Local clients may all be located in the same building or on the same land. Remote clients might be distributed across the continent or planet. The directory itself can be centralized or distributed. If a directory is centralized, there may be one directory server at one location or the directory server that hosts data from distributed systems. If the directory is distributed, there are multiple servers, usually geographically dispersed, that provide access to the directory. When a directory is distributed, the information stored in the directory can be partitioned or replicated. When information is partitioned, each directory server stores a unique and non-overlapping subset of the information. That is, each directory entry is stored by one and only one server. One of the techniques to partition the directory is to use LDAP referrals. LDAP referrals enable users to refer LDAP requests to a different server. When information is replicated, the same directory entry is stored by more than one server. In a distributed directory, some information may be partitioned while some may be replicated. The three dimensions of a directory: scope of information, location of clients, and distribution of service, are independent of each other. For example, clients scattered across the globe can access a directory containing only information about a single department, and that directory can be replicated at many directories. service or clients in a single location and can access a directory containing information about everybody in the world that is stored by a single directory server. The scope of information to be stored in a directory is often given as an application requirement. The distribution of a directory service and the way in which the data is partitioned or replicated often can be controlled or to affect the performance and availability of the directory. 1.2 Advantages of using a directory. An application-specific directory stores only the information needed by a particular application and is not accessible by other applications. Because a full function directory service is complex to build, application-specific directories are typically very limited. They probably store only a specific type of information or do not have the general search capabilities, do not support replication and partitioning, and probably do not have a full set of administration tools. An application-specific directory could be as simple as a set of editable text files, or it could be stored and accessed in an undocumented proprietary manner. In such an environment, each application creates and manages its own application-specific directory, which quickly becomes an administrative nightmare. The same email address stored by the current application might also be stored by a mail application and by an application that notifies systems operators of equipment problems. Keeping multiple copies of information up to date and synchronized is difficult, especially when different user interfaces and even different system administrators are involved. What is needed is a common application-independent directory. If application developers could be assured of the existence of a directory service, then application-specific directories would not be necessary. However, a common directory must address the problems mentioned above. It must be based on an open standard that is supported by many vendors on many platforms. It must be accessible through a standard API. It must be extensible so that it can hold the types of data needed by arbitrary applications. And it must provide for functionality with requiring access to resources on smaller systems. Since more users and applications will access and depend on the common directory, it must also be robust, secure, and scalable. When such a directory infrastructure is in place, application developers can devote their time to developing applications instead of application-specific directories. In the same way that developers rely on the communications infrastructure of TCP/IP, a remote procedure call, RPC, to free them from low-level communication issues, they will be able to rely on powerful full-function directory services. LDAP is the protocol to be used to access this common directory infrastructure, like HTTP, Hypertext Transfer Protocol, and FTP, File Transfer Protocol. LDAP has become an indispensable part of the Internet Protocol suite. When applications access a standard common directory that is designed in a proper way, rather than using application-specific directories, redundant and costly administration can be eliminated and security risks are more controllable. For example, the telephone directory, mail, and web application, as shown in Figure 1-1, can access on the same directory to retrieve an email address or other information stored in a single directory entry. The advantage is that the data is kept and maintained in one place. Various applications can use individual attributes of an entry for different purposes, permitting that they have the correct authority. New uses for directory information will be realized, and synergy will develop as more applications take advantage of the common directory. Telephone directory application, email application, WebSphere application server B, WebSphere application server A, HTTP web server, directory objects all is IBM. Figure 1-1, several applications using attributes of the same entry. Storing data in the directory and sharing it amongst the applications saves you time and money by keeping administration effort and system resources down. Many IBM applications also utilize directories to centralize, store, and share information. The number of applications that support LDAP directories is constantly increasing. For example, LDAP directory support, such as for authentication and configuration management, is provided in various IBM operating systems. IBM WebSphere Application Server, IBM WebSphere Portal Server, IBM Tivoli Access Manager, IBM Tivoli Directory Server, IBM HTTP Server, IBM Lotus Domino and so forth. Next is, inshallah ya Rabbil Alameen, 1.3 LAP history and standards.